Hello and welcome to lesson 1.3 Solve systems of linear equations using substitution. So, the idea behind the substitution method is whenever we have an equation, if we have two unknowns in one equation, we can't solve that. So, we need to get rid of one of the unknowns. And what we're going to end up doing in this lesson is we're going to use one of the equations to isolate a variable, either x or y, and then we're going to find out what x or y equals, and we're going to sub that into the next equation. So, just looking at this one right here, you can see we've got 2x plus 3y equals 12, and x plus y equals 5. Well, the first thing you want to do is we want to isolate one of the variables and make it easy on yourself. If there's a variable that does not have a constant in front of it, then try and isolate that variable. It makes it a little bit easier for you. So, our next step is here we're going to isolate x in equation number 2. So, x plus y equals 5. Remember, when y goes to the other side of the formula or of the equal sign, we have to do the opposite operation. So positive y will become negative y. So you'll now have x equals negative y plus 5. Now what we're going to do is every time we see an x in the first equation, we're going to substitute it with negative y plus 5 because that's what x equals. So here's our original equation, 2x plus 3y equals 12. Now, instead of x, we're going to have 2 times in brackets negative y plus 5. We've substituted what x equals in for the variable x. Now, once we've got this, we have to expand our brackets, and then we're going to collect like terms and solve for y. So 2 times negative y will give us negative 2y. 2 times 5 will give us positive 10. And we have plus 3y equals 12. So now we're going to collect our like terms. We have y's. We have negative 2y and positive 3y. So when we do minus 2 plus 3, that's just going to give us 1. So we've just got y all by itself here. Now y plus 10 equals 12. Remember, when we move that 10 to the other side of the equation, it's going to take on the opposite operation. So positive 10, when it comes over to the other side of the equal sign, is going to become negative 10. So now we'll have y equals 12 minus 10, or y equals 2. Now we've solved for y. All we have to do is in either one of the equations, instead of having y, we're going to substitute 2 in for y. So we'll use the easier equation. That's my recommendation. So here, x plus y equals 5. Well, we can substitute y with 2 because we know y equals 2 for the solution of this system. So it's x plus 2 equals 5. Remember, the 2 goes over to the other side. It becomes a negative. So that's x equals 5 minus 2. And that's x equals 3. Don't forget at the end just to put in brackets your coordinate points. In this case, you'd have bracket 3, comma 2. So if we go through our steps again, step 1, we isolate one of the variables from one of the equations. Try and look for the easiest variable to isolate. If there's a variable that does not have a number in front of it, that'll be an easy one to isolate. Step 2, we're going to substitute whatever that variable equals into the other equation. Step 3, we're then going to solve for either x or y, depending on which variable you isolated. And then step 4, we're going to substitute back into one of the equations to solve for the other variable. So as you saw in the last one, we solved for y. We found out y equals 2. We then substituted 2 for y in one of our other equations, and we solve for x. Finally, we're going to write the solution as a point in brackets, our x value first, comma, then our y value, close the brackets. So I'm going to take you through a couple examples. And our first example, you can use your sheet to follow along. I'm going to use Microsoft Word here. We have y equals 5x minus 5. And our second equation, y equals 2x minus 3. Good news is we've isolated y in both of these. We don't have to do that step. All we have to do is substitute in for y whatever the other equation equals. So in this case, I know y equals 2x minus 3. So I'm going to substitute 2x minus 3 into y in my first equation. So my first equation originally was y equals 5x minus 5. I'm going to substitute in for y 2x minus 3 equals 5x minus 5. Now, I want to get all my x's to one side. I want to get all my numbers to the other side. So I'm going to do 2x. And when that 5x comes over, when it goes to the other side, it's going to be a negative. It's positive here. It's got to be a negative here. Minus 5x equals minus 5. And this minus 3, when it comes over, is going to become a positive 3 plus 3. So now I'm going to collect my like terms. On my left side, 2x minus 5x is going to give me minus 3x. And on the other side, minus 5 plus 3 is going to give me minus 2. Finally, I'm going to divide both sides by minus 3, and that's going to tell me what x equals. X equals minus 2 divided by minus 3. Well, the minuses are going to cancel out, and so all we're going to be left with is 2 over 3. Once we've done that, I'm now going to substitute in 2 over 3 into my second equation. So I know that y equals 2x minus 3. That's my original equation. But I know x equals 2/3. So that's going to be y equals 2 times 2/3 minus 3. We love dealing with fractions. If you haven't had much practice, this is a good one here. So remember, when we're multiplying fractions, we can just multiply the tops and multiply the bottoms. This is like 2 over 1, so we'll go 2 times 2, that's our numerators, and divided by 3 times 1, which is just 3. So we get 4/3, minus 3. We're going to have to get a common denominator. In this case, our common denominator is going to be 3. So we're going to have to multiply that minus 3 by 3 and put it as a fraction. Equals 4/3 minus 3 times 3 is 9 over 3. And as we keep going on there, we'll be able to now solve this. 4/3 minus 9/3, y equals minus 5 over 3. Final step, put it in brackets. We get 2/3, comma, minus 5/3. Perfect. That's the first one. I'll come back and do the other ones after.